Imagine a star so near in cosmic terms that it feels almost within reach, just 437 light-years away. Alpha Centauri A, the primary star in a tightly bound binary system, has always been a tantalizing target for astronomers. It's a sun-like star, glowing with the familiar warmth and brilliance we associate with our own solar beacon. For decades, telescopes have trained their eyes on it, searching for the faint whispers of orbiting worlds. Yet the closeness of Alpha Centauri has made it deceptively difficult to study. Paradoxically, being nearby isn't always a blessing. Its brightness overwhelms even the most sophisticated instruments, and the gravitational dance with its companion star, Alpha Centauri B, introduces subtle wobbles and noise that mask the delicate signals of potential planets. When the James Webb Space Telescope, humanity's most powerful infrared observatory, turned its gaze toward this stellar neighbor, it was embarking on a journey that would push the boundaries of what is technically possible. The anticipation in the astronomical community was palpable. Scientists had long speculated that a planet could exist here, perhaps even within the habitable zone where liquid water might persist. But detecting a faint planet orbiting such a brilliant star requires patience, precision, and an instrument capable of seeing the unseen, a telescope, capable of peeling back the blinding light of a star to reveal the tiny silhouette of a planet hiding nearby. JWST'S advanced infrared sensors offered hope, a chance to see something that had eluded astronomers for decades. And then, in an observation that would send ripples through the scientific world, the telescope detected a potential planet candidate, a faint dot of light hovering near Alpha Centauri A, consistent with what one might expect from a small, rocky world or perhaps a slightly larger sub-Neptune-type planet. The excitement was immediate. Could this be the first direct evidence of a planet in the closest sun-like system to Earth? The team pored over the data, cross-referencing every measurement, eliminating every possible source of error. Everything pointed to a real, tangible object, and yet the story took an unexpected turn. When the telescope returned to observe the star again, the planet had vanished. It was gone. No trace remained. The initial detection was undeniable, yet it seemed to defy the laws of physics. How could a planet appear and disappear in the blink of an astronomical eye? The answer, as it would soon become clear, lay in the extraordinary technical challenges of observing a system so close to home. The brightness of Alpha Centauri A, combined with the complex gravitational interactions in its binary system, can create illusions, transient signals that mimic planets, cosmic dust, background stars, and even subtle quirks in the telescope's sensors can all conspire to produce a false positive. Yet the implications of this fleeting glimpse cannot be dismissed. Even a potential planet detection in this system reshapes our understanding of where planets might form and survive. In binary systems, where the gravitational influence of a second star was once thought to prevent stable planetary orbits, the possibility that a planet could exist here, so close to our sun, ignites the imagination. It invites us to consider that the universe is full of surprises, even in the systems we thought we understood best. Observing Alpha Centauri also highlights an unexpected truth. Sometimes, the closest objects are the hardest to study. Distance gives perspective, but proximity magnifies challenges. It forces astronomers to develop new techniques, to push their instruments to unprecedented levels of sensitivity and stability, and to rethink the assumptions that guide the search for life beyond Earth. For viewers watching this, the story is both thrilling and humbling. Humanity is on the cusp of seeing worlds around our nearest stellar neighbor, yet the cosmos continues to remind us of its complexity. The James Webb Space Telescope, with its intricate mirrors and sensitive detectors, is not just observing stars. It is revealing the subtle dance of light and gravity, teaching us patience and the value of meticulous exploration. Every observation, every data point, is a step closer to answering one of the most profound questions: are we alone? And as you watch this journey unfold, consider subscribing to our channel so you can continue exploring the universe alongside us. There is always another star to gaze at, another mystery to unravel, and every subscriber helps us share the awe and wonder of the cosmos with a community eager to learn, dream, and imagine. In the coming days, months, and years, the search around Alpha Centauri will continue. JWST will return again and again, refining its observations, ruling out illusions, and perhaps one day revealing a planet whose presence cannot be denied. Until then, we stand on the threshold of discovery, witnesses to the incredible technical achievements that make these observations possible, and participants in a story that reminds us of the limitless potential of human curiosity. When the James Webb Space Telescope's cameras returned to Alpha Centauri A, anticipation hung in the air like a thin veil of cosmic dust. Scientists braced for confirmation, hoping to capture the same faint dot of light that had sparked excitement and wonder just weeks earlier. But as the data came in, reality took an unexpected turn. The candidate planet had vanished. The discovery, which had promised a new chapter in exoplanet research, now presented a mystery that challenged everything astronomers thought they knew about observing nearby stars. Was the first observation an illusion? Had the planet shifted in ways physics could not explain? Or had the telescope glimpsed something fleeting, a momentary alignment of cosmic phenomena that mimicked a planetary signature? To understand why this vanishing act occurred, it helps to recognize the extraordinary difficulty of observing objects so close in astronomical terms. Unlike distant stars, where planets create measurable dips in brightness or subtle gravitational wobbles that persist over time, Alpha Centauri's proximity magnifies both its brilliance and the complexity of its surrounding environment. Its light floods detectors, masking faint planetary signals, while the gravitational influence of its companion star introduces minute motions that complicate measurements. Even cosmic dust, interstellar background objects, or temporary instrumental effects can masquerade as planets, creating what astronomers call false positives. Yet, every anomaly provides insight, even when it frustrates expectations. The brief appearance of this potential planet has already taught scientists valuable lessons about the subtleties of binary star systems. It challenges the assumption that the nearest stars are the easiest to study and underscores the precision and patience required to distinguish real planets from fleeting optical illusions. Observing planets in binary systems is a delicate dance. The gravitational pull of two stars can destabilize planetary orbits or cause them to migrate over time, making stable worlds less common than around single stars like our Sun. Yet theoretical models and past indirect evidence suggest that planets can and to exist in these environments. A single observation, even one that disappears, reinforces the importance of refining these models and exploring every possible method to detect these elusive worlds. For the James Webb Space Telescope, the event is both a challenge and an opportunity. Its instruments are capable of observing light across a vast range of infrared wavelengths, detecting heat signatures, and discerning planetary atmospheres even in the glare of bright stars. But this vanishing candidate serves as a reminder that even the most advanced technology has limits and that the universe is constantly testing the boundaries of our understanding. Beyond the technical intrigue, this mystery sparks profound questions about the potential for life in nearby systems. If a planet does exist around Alpha Centauri A, even in a stable orbit around one member of a binary system, it opens the tantalizing possibility of habitable environments just beyond our own solar system. The concept of life elsewhere, once the realm of speculation and science fiction, becomes increasingly tangible with every observation. Each discovery, even ambiguous ones, expands the canvas of what astronomers consider possible. For viewers watching from Earth, there is a sense of awe that cannot be overstated. We are witnesses to the process of science in real time, a reminder that understanding the cosmos is not merely about answers, but about questions, experiments, and the thrill of uncertainty. The vanishing planet exemplifies the unpredictable, almost poetic nature of exploration. For every confirmed world, there are glimpses of others that tease us, challenge our assumptions, and inspire new methods of investigation. The narrative of Alpha Centauri is also a testament to human ingenuity. The James Webb Space Telescope, the most complex space observatory ever built, represents decades of collaboration, engineering, and ambition. Its mirrors, precision instruments, and orbit far beyond Earth's thermal interference allow it to probe regions of space that were once entirely inaccessible. Every observation, whether confirming a planet or revealing a puzzling anomaly, demonstrates the incredible lengths humanity will go to satisfy our curiosity. It is a story that blends technical mastery with imagination, where the faint light of a distant star can ignite excitement across the globe. And there is something profoundly inspiring in knowing that we are part of this journey. Every person watching, every subscriber to this channel, becomes a participant in the quest to understand our place in the cosmos. By following these discoveries, you are witnessing history in the making, learning alongside scientists, and engaging with questions that have fascinated humanity for millennia. This channel is your gateway to exploring the universe in all its complexity, from the subtle wobbles of nearby stars to the violent births of distant galaxies. The vanishing planet phenomenon also highlights the patience and persistence required in astronomy. Confirming the presence of a planet is rarely a matter of a single observation. It involves repeated measurements, cross-validation with other telescopes, simulations, and careful analysis to rule out every possible source of error. Each cycle of observation, even if it returns no planet, sharpens our understanding, refines our techniques, and prepares us for the eventual breakthrough that may one day confirm a stable world orbiting our nearest stellar neighbor. Perhaps most exciting of all is the possibility that this fleeting detection is not a failure, but a glimpse of something extraordinary. The universe is vast and dynamic, and planets may not always appear where we expect them, especially in binary systems. A world could be temporarily obscured by interstellar dust, in an orbital phase that makes it harder to detect, or exhibit atmospheric or surface phenomena that influence its visibility. JWST's sensitivity to infrared light may even allow it to capture planets that are invisible to traditional optical telescopes, opening entirely new avenues of discovery. As we contemplate the vanishing world, we are reminded that astronomy is not just about the objects themselves, but about the story they tell. Alpha Centauri is no longer just the nearest star system. It is a laboratory for understanding planetary formation, binary star dynamics, and the potential for life in nearby systems. Each observation, each challenge, brings us closer to answering questions that have captivated humanity for generations.